Last but one problem, that is count subset. So count subsets, you are given integer array of n positive numbers. Your task is to find and return integer value representing the minimum number of subarrays needed to arrange the elements in a such way that each element is positioned at an index where its value is greater than or equal to its index position. So for example, input n is equal to 5, there will be elements of 5, 5, 5, 1, 2. So we need to arrange in subsets that's in order to get the element in that position is greater than that the index greater than or equal to the index positions. Let us see the explanation. So your given array is 5, 5, 5, 1, 2. The array can be arranged as 1, 2, 5, 5, 5. Here you can see where the value of each element is greater than or equal to this corresponding index. Let us see here 1, 2, 5, 5, 5. 1 is greater than is greater than 0 index, 2 which is greater than 1 index, 5 is greater than 2 index, 5 is greater than 3 index, 5 is greater than 4 index. So in this way you can arrange it in one single subset. That's why output will be 1. For example, for this test case, 8 is the input. So 8 is the n size of an array. 6, 1, 6, 1, 3, 2, 6, 1. Let us see the how many subsets are arranged in order to get the elements in that index is greater than or equal to the index value. So your the elements can be rearranged into subsets 1, 2, 3, 6, 6, 6. That means the every element in that particular position is greater than or equal to its index value. So in that way we can arrange it in a 3 subsets. 1, 2, 3, 6, 6, and 1 is another subset, and one is another subset to meet the requirement. So 3 subsets are formed, hence the output will be 3. How this problem was solved is, so take the input, use scanner class. Scanner is a class to take input from the user. We created the object for the class, and this is the syntax for the scanner class. Next we take the n value and we take the input using this block of code. We created the tree map. So why tree map means this logic is simple. So we created tree map. It is one type of data structure. In that data structure, we have methods called key sealing and sealing key, and there are some methods in tree map. Those are so simple syntax is that we need to create a tree map using tree map, and we can write wrapper cases what will be stored in that tree map data structure. We can simply put the values key and value pair. It is similar to the hash map, but it is a tree map. It will change in data type storing data. So we in this particular code we use called sealing key. I can simply explain this logic that by using this test case, 861613261. So what here, we created a tree map and we traverse to every element of an array and put it in the tree map with the value of that particular key, and its value is simply a frequency. If the element was not in the array, we put similar, we put default value 0. If already in that tree map we get the value and plus add, this means we creating a frequency for the elements in an array by this logic. So how it happens, so it is tree map, looks like 1 is the key value. It will be repeated as 3 times. So 1 is 3 times, and 2 is 1 time, and 3 is 1 time, and 6 will be as 2 times. So this is exactly how tree maps looks in our case. So what we are doing is, so uh, next part of logic is, so we are traversing every element until the tree map was empty. We take the position variable called 1. And seal key means we are taking the next greatest element which is greater than or equal to the position of x. This means position will be 1. The element which is greater than or equal to the 1 will be get as key here. If there is no such elements, that is means key will be equal to null, and this loop will break. That is what logic is. Explained on the screen. So let us see. We are getting initial we have elements, right? One, two, three, four types of elements, and their frequencies. So what we are doing is, we are taking position equal to 1 initially. We are taking the element which is greater than or equal to this number. So we can get the value 1 here, that is key. This key we will get into key equal to 1. That is what exactly happens here. So ceiling key means that that greater element in that position are equal to that position. That element will be get it as key. We get the value of that key. If the value is equal to 1, we remove it from the hash map, or else we decrease the count of the count of that particular element. So in this similar case, we are taking the position 1, we reduced this 1 to frequency to 2. That is the logic here. We reduce the key value c minus 1. We reduce the count of that particular key to minus 1. So again, we are having position plus plus right here. So here we have position plus plus right. So the position 1 will be incremented to the position 2. That means position 1 will be incremented to position 2. So now the position 2, one element which is greater than or equal to 2 position in this array, we get the least which is greater than or equal to. So since the key will be here 2, 2 is the element which is equal to this particular position. So 2 is the element, and we reduce the count to 0. If the count of that particular element was 0, we remove it from the tree map. That logic was here. We remove it from the tree. So next, position equal to position equal to position equal to 3. So position equal to 3, the element which is greater than 3, we will get it as this element, and we, because the count will be decrement, and here we get key value equal to 3, and count of that particular will becomes 0. Then we remove it from the tree map, and now the position will be 4. The element which is greater than or equal to this element is 6, right? 6 is the next greater than or equal to next greater than element to the 4. So we take it as key for the position 4, and we decrement to 1. This element was not removed from the tree because it has count 1. And then position equal to 5, we take the one more key and decrement the 0. And whenever the this position, whenever the count of this element becomes 0, we remove it from the tree map, right? So then position will be 6. There will be no such elements in the uh, tree map. So we stop the loop will be stopped here. right? There is no such elements. This is one part of iteration for this loop. So this will still still we have in tree map we have one element which is having count 2. Still the tree map was not empty, right? So still we are doing while loop execution from initially again one more time. In this process we group the elements, right? We group the see in this here we take the key values of initially 1, 2 and 3, 6, 6, right? We are taking elements 1, 2, 3, 6, 6. This is one of the subarray. We grouped it and we are taking one more count called z equal to 0. Now the z value will be, we have grouped one group that will be 1. So still we remains with key same position starts with 1. So we have 1 greater than we want the element which is greater than or equal to this one. That is the exact meaning of ceiling key here. I hope you understand. So the next value will be key equal to 1 and the count will be 1. And next position equal to 2. There is no such elements which is greater than or equal to position 2. So then we break the L loop. But still we have m is equal to one element with count 1. Right? So this particular part we grouped something called one subset. So again z plus plus we count increment to 2 and some there will be still elements in the tree map. So again we are doing position from the initial position equal to 1, we have 1, key is equal to 1, then becomes 0. Now this subset is one more subset which is having index position value at that index is greater than or equal to index position. So we are creating 3 number of subsets. The count will be, for this one the count will be incremented to 3. We returning that g value, that is 3. This is overall explanation for this code.